We were about 35 people at this moment in the company, and we had a big fire. There was a faulty battery with whatever problem inside, and it took fire. It was really the worst case scenario you can imagine for a company.
Hey guys, welcome back to the Electric Bike Lab. In today's video, we're going to be doing an interview with Alexandre Vallette, who is the CEO of Gouach Batteries. So you may have seen it on social media. These guys are coming out with a brand new battery that's totally repairable and serviceable that's going to allow you to completely rebuild a battery in 10 minutes. It's supposed to be able to have protocols that go with Shimano and Bosch and all of the different e-bike brands. And it allows you to really effectively and at a low cost maintain the life of a battery for 10 to 15 years. Most of the time when a battery goes bad, it's only a single cell, maybe a couple of cells. This solves that problem. Not only that, but the battery is totally waterproof, fireproof, and it also looks pretty good. So we had the privilege of sitting down and going with a deep dive conversation, talking to him all about the challenges of building a battery like this and all of the reasons why he went down this path. And you'll find out that it was pretty crazy what he ended up going through before coming out with these batteries. It's really cool. It's actually available right now on IndieGoGo if you want to support the campaign. So we've got the link in the description. Check it out. This guy was awesome to talk to. I really hope you enjoy the conversation. Thank you so much for taking some time to chat with me. Really cool to meet you. Alex, right?
Yeah.
Yeah, and you're in Paris right now?
No, we are not in Paris. I've lived in Paris nearly all my life, but now we are based in Bordeaux. It's a town that is a bit southern of France on the coast.
Okay. So in France, not too far from Paris, I'd imagine then, or?
Yeah, it's so France is small, so it's 2 hours in train. It's quite far. It's like 700 kilometers, but it's 2 hours by train.
You said it's called Bordeaux?
Yeah, Bordeaux, yes.
Bordeaux. Cool. I'll just check it out. Awesome. Well, yeah, thank you so much for taking some time. Obviously, I want to learn more about you, more about the battery. I guess first thing, how do we pronounce gauche? Is it gauche, gouache?
Yeah, the second one is the good one. So gouache.
Gouache.
Many people tell us that we should change, but it's only the back brand. So we'll see afterwards. It's just a French slang word for saying something that has energy, something that is, how can we say that? Has energy. So we say that for people. This guy has la gouache, meaning that he's really, energetic.
Almost like good vibes. Is it kind of a similar
kind
of thing?
Exactly. Good vibe, but vibes of racing, and it's a bit masculine, a bit too much masculine maybe. But when you're looking for a name for a company, it can be really complicated. And at one point, I just found this. It was available as a .com. It was short, so I just took it.
Short, it's unique, and I mean it has meaning behind it that kind of aligns well. So yeah, props to you. I thought that was your last name. I'm sure you've had that before where people have mistaken it as your last name.
Yeah, but it's not. My last name is Vallette, as you can see.
Vallette, yes. So yeah, thank you again so much. I guess I want to first kind of dive into you and your experience with batteries. I think you've been doing this for a while, because I looked in your Twitter feed, and even in 2021 you had a battery that was able to be totally dismantled without soldering and spot welding. And then on your Gouache website, you've got the battery builder tool, which is a pretty advanced tool. So I feel like you've been at this for a while, but if you could kind of take us back to where batteries kind of started with you, or maybe just like your experience with electric vehicles.
Yeah, sure. So my background is engineering and science. I've done another company more into data science stuff before that. And in 2019, I started. I've been using bikes all my life. I've traveled by bicycle, I mean, So I'm a big fan of bicycle. I use it every day. Now that I have children, I use my cargo bike. I have a bullet for since about 9 years, and I use it for anything in life. It's my car. So I'm a big fan of bikes. And in 2019, I started looking into e-bikes, how they were made, how it was working. And I soon realized that the batteries were often failing for nonsense. So what I did is I started digging into that problem by salvaging all the batteries I could find and analyzing all the cells inside. So I measured the capacity, the impedance, and all that stuff, and I realized that there were more than 80% of those cells that were really good and that shouldn't be in the trash. And so I really scratched my head, and I decided to start a company to try to tackle this problem, because it seemed that it was both technically interesting to solve. It looked like there was a market, and also it was sustainable. I mean, there was an impact on this. So with those three things, I was quite motivated to push on this subject. So we started bootstrapped. At the beginning, it was more a bike shop where we do conversion with kits. So people came with their bags and they went out with an e-bike. So this was sustaining a bit the activity, but also it was a way to really put our hands inside the problem and dealing with real bikes and real problems from people. At the same time, we did some R&D on batteries, and in 2020 we came up with our first patent with weldless tabs that enables to have the contact without spot welding the cells. So it was a good start. Soon after, we had our first contract with a bike sharing company that wanted this technology because they were really into sustainability, and they wanted to have the most sustainable e-bike batteries. And also it was a good business case for them because if you can repair, you can also the total cost of ownership when you rent the battery or when you rent a bike is much better. So that was our first contract. The pandemic hit, so we had to manufacture quite everything ourselves. So it was still in the DIY atmosphere of we even manufactured our own electronic boards and BMS and stuff like that. So it was fun, very difficult.
Yeah, I can imagine.
Yeah, and not really a good idea. As there, it's already complicated as a business, so you should really not do that. But we learned from it. And in 2021, we delivered those first batteries, and then we fundraised because it was a time where you could find money on the VC game and all that stuff. So we raised about 2 million. And with this, we hired a real team of engineers and specialists of batteries, of PMS, of coding, of everything. And we created those batteries. We wanted to go really far. So our company was doing two activities. One was battery design with this new technology. And the second one was battery recycling. So we had contract with many companies that were dumping their battery to us, their dead batteries. We disassembled them, tested all the cells, and put them back into our batteries that we either sold or rented. So it was great because it was the most sustainable thing you could do about batteries. You know, you created batteries from rubbish. So that was what we were doing until 2023. And in 2023, we had a fire in our, so we created a factory because nothing like this existed before. We were about 35 people at this moment in the company, and we had a big fire inside the building due to, now I realize it was inevitable, but because the process was we took batteries from all around, and we didn't assess enough what people sent to us. So at one point, there was a faulty battery with whatever problem inside, and it took fire a Sunday afternoon. And so we lost.
Nobody was there, or
No, nobody was there, but we lost all our stock, and also we lost all our. We had about 1 million of orders in the warehouse. Everything burned, so we lost everything. And this was just before another round of fundraising, so I had no more money. So it was really the worst case scenario you can imagine for a company. And so it was really tough time because I had to fire nearly everybody, all the staff. Otherwise, I had to shut down the company. So this is what I did. And since then, I've been really traumatized by battery fires and stuff like that. So I've worked a lot on this. Because it's really a pain, when you're a battery manufacturer, your job is to put as much battery out there, and if those battery could catch fire, or you cannot sleep at night anymore. So it's horrible. So I had to solve this problem first, and the second is that our customer were mainly free floating companies. And so the free floating companies, the batteries, they stay out all year long, under the rain, under the heavy sun. You have people tempering them, so they had some fires sometimes, of 1 or 2 batteries and stuff like that. And it was really scary. It's not a good thing you cannot work like this. So I really focused my energy on fireproofness, and now it's working quite well.
Wow. So Gouache, the company itself, you're making this infinite battery. That's sort of the newest project. Right now, you're also in the manufacturing and design of batteries. Is that kind of how the company's encompassed at the moment?
Yeah, at the moment, so we have 2 activities. We have B2B, where we sell batteries to big companies, and the other one is this new project Infinite, where we try to have some feedback from B2C, from people, because I'm really tired of working with other companies. I'm really bad at sales. I'm really a bad salesman. So when it comes to discussing a contract and stuff like that, I'm so bored, and it's always ending in the same way. People, they come with sustainability, and we love all the features that we have, but Chinese pack are like $100 less. So
way cheaper.
So I was tired about that. So I wanted to have a feedback of the community of real people. And so this is why I launched this Kickstarter / crowdfunding idea, just to have feedback, of real people. So this is what we did this summer, and the feedback is great. I've received like 500 emails of people saying that's how batteries should be made. We want some. So it's really encouraging. And we are launching next week. So I'm really struggling on the work of finishing, this campaign, because it's a lot of marketing work and stuff like that I don't really know how to do, but it's really interesting.
Wow, that's awesome. I mean, yeah, when I first came across the infinite battery, the fact that you're able to take it all apart, it's with basic tools, and in 10 minutes you can completely rebuild the pack. All you need is cells. It's just contacts. There's no welding, there's no soldering. It looks brilliant to me. It looks like a really and I think there's so many implications there, right? So for one, you can repair it yourself. 2, if you want to just have a battery that lasts your entire lifetime, you're basically 1 or 2 sets of cells from being able to do that, right? Another is like, so an implication could be traveling with the battery, right? Like you could disassemble the pack completely. I'm sure that has some implication with airlines where they don't allow a battery on, but cells is a little bit different, possibly, right? I don't know the exact specifics there, but, and then also, is it a stainless steel encasement? Is that what you guys are using to contain it all in?
Yeah, so to come back to the different things you mentioned, so transportation is one. It's a good thing. You cannot travel with a big battery pack. You can travel, however, and it's really absurd, but it's like that. You can travel with as many 100 watt hour packs as you want. So if you have your 500 watt hour battery that is dismantleable, you just have to do five pieces like this, and you can take the
Many packs.
Yeah. So that's the first point. And after, so yeah, the solderless is the baseline. And in the infinite battery, what we did is this casing we tried to make something that could replace the A-long batteries, because we see a lot of those packs everywhere. So yeah, the shape is sorry about we need to remove the effects. But yeah, the casing is the new casing that we developed in order to have. So yeah, this battery case is in aluminum. The good thing about that is that you can have a very good gasket, so you have really a nice waterproofness also, which is really important. Because from our experience with free floating, water inside the battery is really a pain, because it will either make your battery dangerous, or at least it will kill your electronics. So we should really remove the water. And the fireproofness also is due to so we did quite a lot of engineering about that, and we are able to diffuse the heat generated by the thermal runaway of the cells, but there is no flames coming out of the pack, which is good, because what you don't want is those propagation where you have all the cells that fly away inside your garage. That's what you don't want.
Just spreading. So that your design still allows the venting of the cells. It still has enough room for the gases to expand.
Yeah, let me show you. Just a minute, I will come back with it.
Yeah.
So yeah, the principle is that you have two spacer in plastic. So this is ABS, and then you have the contact plate. So this is not the infinite battery. This is another model that we have. And you see, this is a PCB. So yes, the good thing about the PCB is that you can incorporate many things automatically inside the PCB. For example, we can put as many thermistants and measurement of temperature as we want on the board. And that for nearly free, because it's just like one tiny SMD component that you can incorporate in it. You can have some fuses, you can have everything. So what you have is like two pieces like this, and then you put yourself inside. And once you're finished, you just have to plug it back like this. So that's the idea. And in the infinite battery, it's the same model, and it fits well inside the casing. And for the venting, you will have, if a cell vents, the gas comes out from this, and it will circulate around like this.
So that's really interesting, because a lot of even batteries that are fully potted, potting is good, but then you eliminate the ability for it to vent, and it kind of remains contained. And I've seen potted batteries can catch fire, and when all the heat is inside, right? So that's I know that cells are designed to vent and but you need the batteries designed to be able to use the feature of venting. So that's cool that you guys have looked at that in a unique way, and your cell spacers completely cover the cell. So most cells, it's just the ends that are covered, right? And then the middle is all kind of a shared mass. So yours are totally isolated in that way, which is, you don't see that a lot. So can you talk about some of the other engineering innovations that you guys have come up with? Obviously, a lot of thought has gone into it.
So you have different innovation. The one innovation is about repairability. So it should be really fast and easy to assemble the pack. So we had to think about how do you place the pack inside the casing so that it's maintained and centralized. So you see those two spacers that you mentioned have those things that will center and fix the pack firmly. It's really simple, but it works really well. Other thing we have, so on the BMS, we have connectivity, because so when I mean connectivity
Bluetooth,
is like
right?
Bluetooth and Wi-Fi. Wi-Fi is
And
good
Wi-Fi.
when you split, because the Wi-Fi is long range, so you can. It's also much more data. You can transmit much more data through Wi-Fi, and so on the fleets of bikes that we operate, they are. When you can do an over-the-air update of the batteries, and you can update like thousands of battery at the same time just through one call.
Interesting.
So that's interesting to have the Wi-Fi. You can also hack a lot with the Wi-Fi, so you can geolocalize the battery quite well inside the cities, because you can triangulate with the Wi-Fi's. So we are working on a solution using something like that to be able to locate your battery, even though it has no 3G or whatever, or GPS.
Yeah, no SIM card. Yeah.
Yeah, SIM card would be too expensive, I think, for a battery.
Of course, yeah.
But just the Wi-Fi and a bit of hacking can do the job. So that's about the connectivity. It's also useful to have the connectivity, because we are constantly updating the firmware, and so you can have updates. But also we are trying to create two kind of libraries. So you would have one library for different models of cells, because one BMS has some parameters that are proper to one cell. And so if we let people, it's the first idea about repairability is really simple, but after when you pull all the thing, you see that there's a lot of complexity that nobody had to think about when you are doing the usual stuff. But us, we have to enable people to change the model of sales and to find the right reference. We have to let people also change possibly the protocol of communication between the battery and the rest of the bike. So that's about the compatibility. We are trying to make something as most universal as possible. So if you have a Bosch battery, you should be able to select Bosch, and the Infinite battery speaks the Bosch protocol. So for this, you really need the connectivity in order to maintain, all this knowledge about the battery.
Yeah,
and after,
so that's a lot.
Yeah, sorry. Tell me, I'm speaking too much.
I'm just saying that's a lot to incorporate all the protocols. Every cell is a little bit different, so you might have some low voltage cutoffs of some cells that are a little bit different than others. Other factors as well that are involved there. How hard was it to get the protocols, like to get them all working? And like, were you able to like contact Bosch and just say, hey, can I have your protocol? Or was it like you had to kind of reverse engineer all of it?
Yeah, it depends on the companies, but most of them will never give you their protocol. All those companies are really closed. Bosch is a good example. We know them quite well, because in 2022 I did a lot of lobbying myself with me and myself, because I was the only guy in front of the armies of Bosch lobbyists at the European Union, because there is this new there is new regulation. How do you call that? New law around the regulation. Thanks you. The new regulation about batteries, and people in the politics were quite aware that we could do much better about batteries and repairability and refurbishment and recycling, because we didn't mention it, but the fact that you can also remove the cells individually makes them easier to recycle. So what we were doing was quite in line with the people doing the regulation. But in front of them, you have experts from Bosch that will explain to the regulator that we need to keep things really close. We need to have batteries manufactured only in battery factories, and nobody should tamper on the battery, which is quite understandable, because if you take a normal design of a battery, when you try to make a reparation, it can be really dangerous if the person does something wrong, and after you don't know who is responsible. So I can really understand the position of Bosch and other big OEMs. And we are here like really a bunch of bad kids trying to disrupt a bit the system. So they hated us for that because we gave them a lot of work. But in the end, we managed to have one text in the regulation that pushes the companies to do more repairable batteries. So we'll see if we can push on that. But just as a conclusion, we know those people from Bosch and other big companies, and there is no way they want to open their system because they want to maintain a level of quality and of safety that's only possible when everything is closed. So what we had to do is reverse engineering most of the protocol. Some are easier than others, but it's a lot of encryption. It's really difficult.
What are some of the other challenges that come with a battery project like this?
It's so many challenges because it's hardware, so you have to manage the manufacturing. You have to find the right partners for different things. So we have basically plastic parts, aluminum parts, electronics, and for all those suppliers, you have to assess their quality, if they work well. So we worked with so many suppliers in the past years that we learned a lot, but it was really difficult. Then you have all these regulatory things about certification. So you have to pass the different certifications. So we passed IEC 62133 and UN 38.3. We will pass the UL US certification, but we have to wait until we have the final. So this is a CNC version of the casing.
Prototype.
And so we are launching the tooling next in 2 weeks. And once we have done the tooling, we will have the final pieces, and then we can start the UL. So that's cumbersome and expensive. And after, the logistics of battery is so complicated. So that's really a pain. However, the fact that we sell in kits is really good. It's great for us because our vision is that we want to decentralize battery manufacture, repair, and recycling. And this is why we invented this product made in kits, so that we can ship easily the battery without the cell. And locally, what we do is that we have some partners that will ship the 40 cells that you need to make your batteries.
Right. So are those metal enclosures, are they going to be cast, or what manufacturing method? Cast. So does that pose for future an expansion? I'm guessing right now, are you using 18650 cells?
Yeah, because they are the most. We have a lot of people in the community that liked upcycling, and so we kept this format because that's where you can find the most upcycled cells on the market.
Yes. So I guess with anything, there are probably plans to make more models and stuff like that. What do you see in the near future on the horizon in terms of model offerings or plans for expansion?
So our goal is, so we do step by step because it's already so much complicated that we concentrate on this one. The good thing is that it seems that there's a lot of people that want it and like it. So we want to, as I told you, so we launched this crowdfunding next week. We launched the tooling. We sell this model to B2C via this crowdfunding, but also in B2B to brands that can equip their bikes with this model. So we hope to sell a few thousand at the beginning. We already have a few customers in B2B that could add up. So this finances the tooling and all the certification and all that stuff. And if it's successful, then the plan is to do, I think, at least two or three other e-bike models of batteries. So one would be a tube battery. because we see a lot of companies that want to integrate the battery inside the tube. So that would be one model. Another one would be a rear rack, because there's a lot of retrofitting to do with rear rack batteries. And the third one would be a bigger capacity / voltage battery, so a 52 or 72 volt battery, more for the US market of big fat e-bikes, most probably in 2170 cell.
21700. Awesome. So right now the configurations are, it's a 36 volt 10S4P, and then is it also offered in a 13S3P? Yes. Okay.
Exactly.
So that's really tackling a huge amount of the market's desire anyways in those two formats. That's a really good first ones to go through. Yeah, that's awesome. So it's basically, it's pressure, right, that is being applied when the case is compressed, and it's similar to like the Vruzen, if you're familiar with those. You guys basically did that, except much more refined approach.
Yeah, I've used the Vruzen once. It's quite different, because the Vruzen is using some springs inside their caps, right. So it's good, the Vruzen, because it enables people to do whatever shape they want. The downside of it is that it takes a lot of space, so the density you can achieve is quite low. And second, you have to wire a lot of. Once you finish your pack, you have all those wires going everywhere, and so it's not very neat once you're finished. You always have a problem of a wire disconnecting from one part of the battery. So I'm not a big fan of Vruzen, and also sometimes I had quality issues where the spring didn't make the good contact. So no, what we do is that we use directly the PCB as the spring, because PCB material are really stiff, and so you can apply quite a lot of pressure on the cell. And the good thing about that is that it's integrated. I mean, once it's done and in production, it's simple. It's like 2 plates, and you can mass produce them automatically. And it's quite easy. It's also safer, because as I told you, you can include fuses and per cell fuses. So even if a customer just reverse one cell, it doesn't do anything. It will just burn the fuse, and you have to repair, but that's all. So no, it's quite different from using it. I would say humbly, because I know the guy from Vruzen, and I'm a big fan, because I really like his influence on the e-bike community and on the DIY community. So it's clearly one of our inspiration. But I hope, with all the money that we spent on the development of this battery, that we are just one step ahead.
Yeah, for sure. So one question I have is, what would be like the maximum current flow that the PCB contacts are able to support?
Well, it's very high.
10 amps per second. Very high.
Yeah, because you can decide on the amount of copper that you put in your PCB. So at the moment, we can pull more than 25 amps per cell without any problem. So for most e-bike case at the moment, it's covered. If we want to pull more, then we'll see. But at the moment, for small mobility like this, it's not a problem.
What would be like the limit? Is there a limitation, like on the BMS, what it is able to flow, or what would be kind of? I know it's running XT60 connectors, which are 60 amps. Kind of is their rated current. Is the whole pack, if you put high enough discharge cells in, would it be able to flow 60 amps?
No, a bit less. The BMS is designed for 30 amps continuous.
Okay.
And after in peak, you can do a bit more, like 35, 40, depends on the length in time of the peak. But it's designed for 30 amp continuous, which brings us at nearly 1 kilowatt hour, 1 kilowatt.
1 kilowatt, yep.
Yeah, so we think it's really more than enough for an e-bike. The battery again is really designed for e-bikes. So it's me. I ride it with a bullet bike, sometimes very heavily charged, and I really feel it's much more than enough.
Yeah, that's gonna. I mean, you got like in America, the Bafang BBS HD is a super popular motor. That fits right in line with that 30 amps. A lot of the even more powerful mid-drive motors that would take care of. So that's a good amount of current, which is awesome. So, yeah, what from a manufacturing standpoint, what would you say is like the hardest thing to tackle? Because obviously the dies for the metal enclosures, I'm guessing, are those cell brackets going to be injection molded?
Yeah.
Yeah. So I guess you just so many different manufacturing methods. What do you think has been the hardest so far?
All of them. All of them were really hard. We had problems in the previous years of quality on the PCBs, on the connectors, on the electronic component that we used. So yeah, it's really tough to maintain a good level of quality on the product. So I hope we learned the all those lessons before, but as you know, you're never. I'm always waiting for new surprises.
Right. And so the fire test that you guys did on in one of your videos, you had a kind of a typical, I believe it was like a high-long or some kind of plastic shelled, and then you did your battery on the other side, and you guys poked a hole through the one battery, it caught fire, turned into a horrible flame. And on your battery, you had a thermal probe hooked up to one of the cells and got it to go into a state of thermal runaway, and it vented, and then it just kind of, and that was about it, right? It didn't propagate or anything like that. Do you foresee any scenario where a fire could take place? Like say if the battery was thrown off a building or something like that, or just had like a huge impact. Like what are other things that are causing batteries to catch fire? I know with the battery on the left, it had something penetrate right through the cell, right? So, and that wasn't carried on the other test, but obviously you have a metal shell as well. So it's way less likely for something to just penetrate through the aluminum shell. But
yeah, I'm gonna do this test again because I wasn't happy about it. But we operate with we don't do it in labs because it's too complete. It's too expensive and too complicated to plan. The correct slot in the lab, and so we do it ourselves. And so the setup is quite complicated. You have to go on a place where you cannot put fire on anything and everything. So it's quite complicated. And so what happened is that normally we always launch the pack with the thermal pads, but for some reason it didn't work, and the thermal pad that we bought were not good, I think. And so we had only we launched the Gouach battery first with the thermal pad, and after we had no more for the bash. So this is why I started it with a screw, because I really wanted to have an image. On the new I think on the new example I will start both with a screw, so nail penetration test. So this way it's completely equivalent. I will drill a hole inside our casing and put a screw. Also because it's much easier, to just put a screw inside the battery. And so the second aspect that didn't work as expected, so it's a good thing, as you say, it didn't propagate it. So we had only 4 cells that burnt inside our pack, but it's normally it's a good thing. Normally you like it when it happens like this. Of course, here I wanted to have everything burning inside the pack to see that the casing could withhold this. It didn't happen. So next time, hopefully, the complete pack will burn inside the casing, and in other tests that we did before that we did not film, we managed to have this and have a complete pack burnt inside the casing. So this is the final and proper test I want to make. Hopefully next week. I'm not sure if I will have time, but hopefully next week I will do it.
So with the casing being aluminum, is there worry that the casing will melt?
Yeah, it can melt. It can melt. This is why I need to have all the cells going in thermal runaway. So it can melt. However, what we engineered is a way that the casing is designed, not only the casing, but the pack itself plus the casing is designed so that as the cell propagates between each other, the release of the energy will be radiated by the casing. So it's an equilibrium that you can find between the energy that is radiated by the casing and the energy that is put into the system by each cell going in thermal runaway. So yeah, there are a few equations on that I wrote. It works well. Yeah, it works well.
So the casing itself, does it have venting to the atmosphere?
Yeah, because you have quite a lot of energy that will exit from the gas. So you really need to have a venting system in order to evacuate this energy.
And it's a one-way valve?
That doesn't matter because when it starts, what you need is a valve that is waterproof. But once you have a thermal runaway, what you need is just pull out this.
Yeah. So it's basically, is it like kind of like a plug basically, and that will release once there's enough pressure inside, and then it'll allow it to escape?
Yeah, it's kind of a plug like this, yes.
Okay, cool. Very cool. That's awesome. So do you bike all the time right now still with an e-bike? And is that one of your primary modes of transportation?
Yeah, of course. It's my I have the chance to live inside the city center, and my kids, their school is nearby. My job is nearby, so it wouldn't make any sense, to use the car. So I use the bike. I haven't touched my car for about 3 weeks now. It's only good to go on the weekends.
Yeah, that's awesome. So how long has this project been in the works for, the infinite battery?
Oh, the infinite battery is quite recent. I designed it. We designed it because I worked mainly on the casing, and people of my team on the electronics and the rest. It was designed from June. We started.
May, June. Okay. And I guess what helps with a project like this is if you didn't have any experience prior, it would take years to develop something like this, but you've been doing this for years. So this is kind of just another product that you guys are offering, essentially, right?
Yeah, it's exactly this. And I think it's going to be our only product. The goal is that we took all that we've learned from battery fires, from repairability, from operating batteries outside with waterproof issues and all that stuff. We took all this knowledge and put it in this model. So my goal is to have only this model for now. And after, if it works well, then we'll do other model on the same design principle. But that's the best thing that we've done for the moment.
Awesome. Yeah, that's super cool. I think it's an amazing idea. I almost can't believe that it hasn't been done, right? Like it's I mean, it's timely. At least it's being done now, but it's kind of crazy to think that that this kind of approach hasn't been done yet. So I think it's awesome that you're leading the way, that you're on the forefront of this, and that you're obviously very personally invested. Battery fires are scary, obviously, especially I can only imagine with the warehouse that you guys had that went down. That must have been just a horrible, horrible experience. But I guess you're able to use that as fuel for inspiration for, making a product that won't allow that to happen to anybody else. Pretty awesome. I guess last couple questions for you. So obviously the launch is next week. Are there any, is it just marketing? Is basically everything pretty well set up, ready to go? Or are there any big hurdles still that have to be overcome before products are able to start shipping out?
No, it's quite, as you said before, we've been doing this for 5 years. So if it was our first battery, of course, production would have been years ahead. but no, we already have our partners in Asia for plastic, for casting, for that stuff. We already sent. So what I showed you is, the last, we CNC a last version just before going into tooling. So we are quite advanced on this. The electronic is quite fast. We've done a new design, and we are receiving the last design this week normally. That the one that will be in the infinite battery. So we already will have 10 samples this week to finalize the test. But it's not really different from what we did before. It's just a rerouting of where you put the components in order to make it smaller. But it shouldn't be too difficult. So hopefully, if everything goes well, by the end of the year, we should be able to ship there. And after, we never know. You can have issue on the production line, on the tooling. Sometimes you just realize that you need to redo one piece. So the optimistic scenario is shipping by the end of the year.
Awesome. So one other question: if somebody has a 36-volt pack and then they want to move to a 48-volt, does a whole new setup have to be purchased, or could the internals, will they be available for separate purchase if somebody wanted to switch over to 48-volt?
Yeah. On the Kickstarter, no. It would be too complicated to have too much parts and everything. So
down the road.
Yeah, you just have to choose one or the other. But just after the launch, I will create some kind of online boutique or whatever, where you can buy spare parts, BMS, just the BMS, just the charger, just the handle if you break it, things like that.
Awesome. And where will they be shipping from Asia, or will you have a distribution center in Europe?
Yeah, I'm exactly into those problems. It's a nightmare at the moment. It's my current nightmare. But yeah, we are going to a solution where we have shipping from Asia but in bulk, and we will have a warehouse in Europe and a warehouse in the US. And the warehouse in the US will also spread to Canada and neighboring countries like that.
Good. You're not forgetting about us Canadians.
No, I love you guys.
Right?
Yeah, I've been there so many times. I know quite well the Canada. I met. You must know this guy, Dustin from ebike.ca.
Justin.
Yeah.
Or one of the guys from Grin Technologies, or
yeah, exactly. This guy.
I mean, that whole company is awesome. There are a lot of really good people working there. Who did you meet? The owner? Or?
Yeah, the founder.
Okay,
Justin.
Cool.
Yeah. I met him at Eurobike 1 year ago, and we had a chat, in a corridor where I just showed him our battery, and he was really enthusiastic. He said, "Wow, that's so neat!" And I hope to work with this guy once. He often comes to France because his wife is French, so I should meet him soon. I hope.
Cool.
Can you tell me more? I'm curious about Electric Bike Laboratory. Can you just tell me a bit more before we end this call about what you do? Who is your community? I've seen before that you have many motors and many e-bike parts behind you. So I'm curious about what's your activity.
We are kind of like when you were doing conversions in your home shop. So we do conversions. We do a lot of batteries, some battery design. We build a lot of the batteries here in house, and we're a smaller Canadian company that's just got basically an e-bike shop that we're running and trying to do cool projects, trying to make cool batteries. I personally love batteries. That's kind of my main passion is we deal with a lot of batteries. So we've repaired a lot of batteries too. I totally know the pains that you've gone through. We've had where people would drop off a battery to get repaired, and then us trying to disassemble it, one of them caught fire. So it wasn't even one of our batteries, but it was like, man, this is crazy. And it wasn't even a big fire, but it was obviously such PTSD inducing that a lot of batteries, we just said, sorry, we can't touch these because the liability is too high. Some of the batteries that would get manufactured and they'd get pressed into an aluminum case were such tight fitting, and then when you try to pull it out, it would score the side of a cell, and then it would cause the entire case to become conductive, and it was just a nightmare. So we're trying to stay away from those a little bit, but like you said, so many of the batteries that come in, it's one cell bank often that's dead. It's even sometimes it's a BMS wire that has lifted. It's 90% of the pack is good, but it can still be pretty destructive to even replace one cell, especially the ones where they're vertical and then there's cells that are inside in the middle, and it's basically like, you know what I mean, where you have to disassemble the entire pack in order to access cells in the center, and it's just a nightmare. So it's a shared pain for sure. And sleepless nights where you don't want something to catch fire. I know where your head's at there. So I absolutely love what you're doing. I think it's awesome. And super cool to be able to talk to you, the person that's kind of behind it, or at least, the main guy steering the ship. It's really cool. And I'm excited. I'm on the list. I can't wait to try one out. And I honestly think it'll just make things so much easier, right? Where if for example, e-bikes, like for us to be able to send somebody a bike and then send them the battery and then just send the cells, it would be so much easier than worrying about all the logistical nightmares are associated with batteries, right? We try to be as local as we can to avoid that, but it's, I think your solution just makes things so much easier. And also the safety side is just as important as the ability to repair. And it just makes battery ownership, so much less daunting of a feat, right? A lot of people are, of course, scared about these lithium batteries, and rightfully so. I mean, there's how many apartment buildings have caught fire, in the subway stations, bikes catching fire, and randomly, and a lot of it is because of really low grade cells that are from China, where e-bike manufacturers would choose them because they're slightly less expensive, $100 less expensive. But if you have a system where you buy the best cells and then you're just putting them in yourself, the labor is gone. So all of a sudden, it becomes so much more economical. If you need to rebuild it, you just put in a couple more cells. I mean, it's such a, it's the way it should be, right? Like, that's because, funny story. So we had lithium cells that were we were discarding, and we were discarding at a local landfill. And I was like, do you guys take lithium batteries? And this was like a place where hazardous waste goes. And they're like, yeah. And then I had a box worth, and the guy was like, okay. And he grabs the box and he just dumps it into a trash can, like a huge trash can. And I was like freaking out. I'm like, oh my God, this is going to catch fire. I was just, I couldn't believe that this guy did that. Like, it was no big deal. No fire caught, but geez, I was like, I'm like, is this whole thing going to burn down now? Because it's all these other chemical products that are all around it. And I just couldn't believe it. And it was, a lot of those cells were probably still good, but they were, in battery packs that wasn't worth ripping apart and tearing down. So, oh man, I definitely I feel the pain. I feel the pain from where you're coming from.
Well, that's great. It's really nice to hear this story, because me, I'm working for people like you. My ultimate goal is really to spread this electric bike way of life, because I really like it. I think it's the cities are even better with those bikes, and so yeah, the more we are to push on this direction, the better it is. So I will send you a sample as soon as I have one. This way you can play with it, and
If you
hopefully
need us to do any tests, let me know. We can definitely put one on fire and video it. If it takes anything off your plate, happy to do it.
But as soon as I have enough of those aluminum casted, because the one I have in CNC are costing me a fortune, so I cannot send too much samples. But as soon as I have the casted version, I can send you a sample.
That would be awesome. Yeah, totally would be happy to try that out, and any kind of feedback that we're able to give back to you would be awesome. I do want to respect your time. I really do appreciate the time that you've given. Super excited for this. So Gouach, it's a Kickstarter project right now, right?
No,
so
it's IndieGoGo. I'm gonna send the mail to now, like in half an hour. That explains that we are going to IndieGoGo in the 1 week.
And what is the MSRP of the shell itself, like the price? What are you selling? How much are they selling for?
So you mean the MSRP of just the kit without the sale?
Without the cells.
So MSRP would be like 300. 300. Let me check, because you have the charger inside. You have the plate to fix on the bike. And with this, it's like 336 MSRP.
Okay, and that's euro, or is that USD?
No, dollar. USD, sorry.
USD. Okay, awesome. So you got that case, and then you have a battery that will basically last you forever, and you can replace the cells with cells that are, you can find, you can probably replace all the cells in that for between $1 USD and $3 to $4 USD for, depending on how high end you want to go. Yeah, I mean, the math makes sense right away, and it makes even more sense down the road, right?
Okay, we'll see. I hope in 1 week we will have some success on the campaign. If you can share the news to your community, I would be glad. But we'll see. And after, I'll send you samples.
Yeah, we're planning to put this video on YouTube. Is that all right with you?
Yeah, sure, no problem. Great.
Yeah. Okay. Awesome. Well, thank you so much, Alex. Really appreciate your time. Really excited for this. I do hope to be able to catch up with you again sometime in the future.
Great. Thanks.
Okay. Awesome, Alex. Have a great day.
You too. Goodbye.
Bye-bye.
Well, guys, I really hope you enjoyed that video. I know I love talking to Alex all about batteries. For me, it was super cool. Also, just a super nice guy. I really think that this product that they're coming out with has some serious potential, and it can really alleviate a lot of the concerns with e-bike batteries, especially fire hazards and then batteries dying on you early because of simple things. So check out his IndieGoGo campaign. It's on live right now at the time of this recording. It looks really promising, at least worth checking out. But always, guys, thank you so much for watching this video. Really hope you enjoyed it. Be sure to subscribe, like, drop a comment, let us know what you think, and we'll see you next time. Be sure to keep it on 2 wheels. Thank you guys so much for watching this video. Make sure to drop a comment. Let us know what you think. Let us know what you'd like to see. We want to hear about it. And if you want to watch another video, click on this one right here. Or if you want to see what kind of e-bike stuff that we've got, check out this link right here.